All right. From toothbrushes to CCTVs, let me introduce to you Robert Kugler from Kugler ITS. Warm applause, please.
So thank you very much. As we all know, we are watched by toothbrushes, now also IoT cameras. So I'll be talking about IoT-CCTV devices and their miserable security. Okay, first of all, I'll show you my to-do list for today. As a first, we will talk about a little bit about me, who am I, what I do, and then we'll switch right into IoT CCTV devices and their security. A little bit of history and yeah. Okay, right after this we'll switch to the device itself. I will show you how I found what I'm presenting today and how easy is it to exploit it in a new way, because this device is rather boring. We all know all these devices are terrible, insecure, and exploitation is trivial. Okay. So about me, I started to learn web and application security at the age of 14. So I'm quite a long time in the information security industry already. And I got into InfoSec via bug bounty programs, and I'm now working at Kugler ITS as an IT security consultant and head of offensive security department. Okay. Now, as mentioned, to the IoT security CCTV history. Okay, those devices have a long history of being compromised. So we can, I don't know if you can see it, but the first article I found was in 2016 and was an article by Brian Krebs. He talked about IoT cameras DDoSing all around and destroying the whole internet. Yeah, that continued and even led to a web crisis. Okay. Now we'll look at the device itself. Let me show you the device. So that's the device we are talking about. It looks really innocent, doesn't it? Okay. Yeah, the device supports Wi-Fi and Ethernet connections, so it's really easy to get into your network. It has Dropbox support, a microphone, a temperature, and motion sensor. So it's even advertised as an alarm system, so you can deploy it into your home and, yeah, I don't know what you want with it, watching the burglars at your home, or you aren't able to do anything anyhow if they are already in your home. Okay, it has an iOS and Android app. Okay, I didn't look at it, but it might be interesting also. Okay, how do you attack such a device? First of all, you do enumeration. Enumeration is key. So you nmap it, you really read the manual. Yeah, you do it. You check it, you use it as a real customer, so you deploy it and you check how would you fail at something. And once you tested every thing, every feature of that device, you get an idea how the device is working. Okay, and the basic results. Basic access authentication is used. So somewhere in the device needs to be a hash password. You'll find it, but that's later. Okay, weak default credentials. I think admin and no password is used. So, but I found out a lot of customers change the credentials. Okay, no input validation or CSRF protection. So there are stored cross-site scripting vulnerabilities everywhere. But yeah, okay. XSS is, yeah, boring. Okay, CSRF is boring too. So we want remote code execution. Okay. Now we'll look at the firmware. The first tool you would use to get an idea how the file system is working, you use binwalk. You use binwalk to extract compressed data, and hopefully they didn't obfuscate it somehow, or yeah, in this case it was pretty easy. You could use binwalk -e to extract the whole compressed data files you find in the binary blob, and it's yeah, not really a big deal. Okay, you can also combine it with DD and gzip and gzip, because sometimes binwalk is a bit unreliable. So you need to use binwalk for the detection and gzip and DD to split the files. Okay. Now we are in the file system. We look for juicy files. It's yeah, it's a standard Linux system. So check if you can find any private keys or password hashes. Make a list of users if you find them. Okay, but we checked the camera before. Somewhere there needs to be a HTTPSVD file, because basic access authentication is used. So okay, let's have a look. Maybe we can find it, because IoT is famous for backdoor accounts. You can find in almost any IoT device a backdoor account. So I was thinking there must be one. So I need to find it. Okay, but it wasn't that easy. I looked around, and no HTTPSVD file was anywhere, because it was generated later. Of course, the user sets its own password, and then their own password is hashed and put into the HTTPSVD file. So yeah, okay, then fine. Okay, but let's try harder. There needs to be somewhere, if a backdoor account is there must be a string somewhere in the binaries, and often the binaries containing those strings are the PSVD binaries. So the bin HTTPSVD binary or the PSVD.CGI file. Okay, we'll create a short word list with strings. Really not something that special. Okay. Simply pipe it in a text file, no problem. Okay, but now we looked at the firmware. Yeah, we want a shell, so we need to look at it if we can find a commit injection, because IoT and commit injections, okay, best friends. So we need to find and check all fields where it might be possible to find a commit injection. Often those things are hidden in where a server parameter is used, or a SSID parameter. And bingo, SMTP server and SSID parameter on VLAN set CGI and SMTP set CGI were vulnerable to a commit injection. And of course, it's IoT, it's always root. Okay, so I used bin busybox reboot, but I wouldn't recommend it anymore, because what happens is the camera tries to connect to the SSID you injected with your proof of concept at every start. So the parameter containing your reboot payload gets executed every time the camera starts. So you have a really nice boot loop. And sometimes the reset functionality isn't working at all, so you need to send it back to the vendor. Good luck explaining how you got into that situation. Okay, but you can use, obviously, different comments. Okay, because we checked the software and a telnet server is installed. So awesome, okay. We modify the payload and insert the telnet server to start it, because it's not available at startup. So they didn't fuck up so hard. Okay, so we start the telnet server and connect via telnet to it. Okay, now the device is started, everything is running. Okay, the HTTPSVD file is existing. because the user defined his own password. Okay, so, and there we go, admin and supervisor. Admin, we know admin. We are admin. Okay, but supervisor, who's supervisor? Nobody has heard of supervisor. No word in this manual mentions supervisor. Okay, that's our backdoor account. And of course, hashed badly. So we tried to break it. And we created our word list just 30 minutes before. And because the string is in the binaries, we get it, and it's supervisor dangerous. So dangerous, nice. They knew what they were doing. Okay, let's put it all together into a quick Python proof of concept. So you see, it's not really rocket science. You see, your payload, the SMTP port, but that's not really the basic base 64 encoded credentials. Okay, yeah, boring. That's boring. That's remote code execution. We got root, we are telnet, but that's boring. I wanted it to be a bit more special. So, okay, exploitation. Let's look at it. We have like 100,000 affected devices directly connected to the internet. But yeah, if you only pwn 100,000 devices, that's also boring. We want to go for all of them. So, okay, maybe it's possible to exploit it indirectly. What about a browser? What about combining it with JavaScript? Might be possible to submit the post request containing our payload somehow. I did a bit of research and yeah, it worked. But first of all, let's check the boring exploitation video. Okay, so yeah, we sign in just to show you how it looks like. Okay. Then a small nmap scan to check that the telnet port isn't already open, so the telnet server isn't running. Okay, now we execute our Python POC. Waiting a few seconds because, yeah, the CPU is not the best. Yeah, voila. The telnet port is open, the telnet server is running, and of course, configured passwordless. So perfect, we'll just use root and we are in. Yeah, it's working, but boring. Okay, let's have a look at the indirect exploitation way. I think everybody knows Brute Logic. He's famous for his XSS and CSRF POCs and his research. Okay, last year in June, he talked about embedded credentials being dead because Google Chrome disabled the feature that you can sign in into a device by supplying credentials in the URL, like admin add device. So okay, that isn't working anymore for image tags or iframes. Yeah, that's a bit sad, but they missed something. Okay. You can use JSRecon. I don't know if it's already known. I'll explain a bit how it's working. It uses XHR and WebSockets connections to find out if a port is open, closed, or filtered, and how is it working. It checks how fast the ready state property is changing, and if it's changing in a fast way, you can be sure it's open, and if not, you can be sure it's filtered or closed. Okay, that's not really working reliable on Linux, but it's working pretty awesome on Windows and Chrome. Okay, then you will use image-based fingerprinting. Image directories on IoT devices never password protected. So you choose an image file that is somehow special to the device. The logo of the vendor or whatever you like. Okay, and then you put some JavaScript together to auto-submit a form once the device is detected. Okay, so shouldn't be that hard. Okay, let's show the special exploitation. Okay, first we verify the telnet port isn't open, the telnet server isn't running. Google Chrome is up to date, so I'm not showing any old software here. Okay, and that's our POC website. That's a nice video, and you need to watch it just for a few seconds. So you need to stay on the website because a network scan is running in the background, searching for IoT devices in your network. Okay, so that's running a bit, and all the debug information shows my network is not really active, but it will find the IoT device soon. Okay, the problem is here, if you have a large network, it will take ages. So you need to find a way to better guess the range where the IoT camera is located, or for consumer devices, that's perfect. Okay, easily you can implement it in an exploit kit or something like that. Yeah, should be working perfect. But in corporate networks, you need to find something different. Okay, it detected an app device and it exploited it successful. Okay, the user won't, he will notice that the page changes something different, but I don't know if he will recognize what is happening at all. So we can see the telnet port is open again. We have root access. And that's really awesome because we can reach every IoT device in every consumer network now. And just the limiting factor is time. So we need to get the people long enough on our malicious website. Okay. Yeah, as I told you, the disadvantages are there. You need to have a Chrome and Windows OS to target because on Linux you need to have different times because the ready state property changes in a different manner. Okay, the advantages are obvious. You significantly increase the targetable devices. That's really awesome. And it's easy to build exploit and fingerprinting modules. So just a few lines more JavaScript and you added a different device, a different exploit. It's really awesome. Okay, the impact, it's pretty worse. Affected vendors, I didn't even know how many are there. So we have like 5 vendors where I found a logo and like 20 Chinese vendors with no contact information. And that's just a few vendors I found. Okay. Patches, it's IoT, we all know it. Only Starvidia provided patches, and one nice feature of those devices is they miss an auto update feature. So those patches never will reach the devices. So fun, there's a patch, but nobody will use it. Okay. Resources. I found the OWASP resources on IoT analysis pretty awesome. You can check those out. Yeah, if you don't know Binwork, you can check it out. It's a really nice wiki on GitHub. Yep, you can check out my blog, and there you can view the POCs on SecureIt. Exactly, okay. If you want to contact me, you can contact me anytime. Yeah, I'm working at Calvite ITS. We are offering pen tests and red team assessments. So yeah, just give me a call anytime. Stay safe.
Thank you very much for this nice talk, Robert. Any questions? We have quite some time left for questions. Yeah.
Is it possible to patch it on your own, so you have a way to own it? Can you change the passwords? Can you close the ports?
Yeah, I don't know if you can patch it without breaking some features. Yeah, you could remove the backdoor account, of course. Yeah, you could do that, but that wouldn't remove the command injection vulnerabilities. So somehow a little bit patchable.
Further questions? All right, then thank you very much again.
Thank you.